Hello everyone! In this video we're going to do another example of a program that has structures in it. What's special about this one is we're going to use nested structures. So just like a nested for loop, a nested structure is one that uses another structure inside of it. So what we're going to be doing is creating a really simplistic farm. So this will be similar to the hotel example where we can add animals to the farm. And we're going to keep it simple by just doing an add function and a print function. So we're going to first create our animal. So each animal will have a name, and we're also going to record the sound that it makes. So this will be our created data type animal. Animals are composed of a name and a sound. And we're going to use animals to create our farm. Our farm has animals that live on it, so those are going to be called farm residents. But we're not going to necessarily always have 100 animals on our farm. Sometimes we might only have 3, sometimes we might have 7. So we're going to keep track of the current number of residents with the farm size. So these two pieces define the farm. So this is our nested structure organization. The structure farm has inside it an array of structure animal. We're going to build 2 different functions, one for adding animals, one for printing animals. And what this is going to let us do is we're going to see that pointer notation get used in add. And we'll be able to kind of compare that to a function that uses the non-pointer version, just the normal version of farm. So we can really look at all of the different types of syntax. Okay, so inside main, we're going to create our farm. So this will be a data type farm, a variable of type farm, that we're going to call my farm. And we'll create that with the other variable declarations, like an answer for what the user would like to do. We need to initialize the farm by saying the size should start at 0. Then we can ask the user what they would like to do with the farm. So we'll go ahead and build our menu function. Ask them what they would like to do and give them their options. Remember, we're keeping it simple, so we're just going to be able to add an animal or print all the current animals. and they can quit. So we'll print that menu, what would you like to do? We'll read in their answer, and then we can process their answer. We can use a switch statement like we've been using, or we can use some implicitly nested if-else statements. If one, they want to add an animal, so we would call the add animal function. We need to be careful with our data types. So this function takes in a pointer of type farm, so a farm pointer. And what we have in main is just something of type farm. So we're going to give it the address of my farm so that we match the data types. So this one has to be a pointer, so this has to be pointer compatible. If two, they just want to print, and print does not take in a pointer, so we're just going to pass it my farm as usual. If three, then they want to quit. We're not going to print anything. We're just going to leave this empty statement here. And if they give anything else, then we'll say, sorry, that was not a valid option. And we'll print the menu again and read in their answer again. So now all we have to do is fill in these two functions. So we're going to have an add animal and a print. So we'll take these two functions and fill them in. We've got add animal and print. Now we're going to start add animal by creating a new animal. Animal is a data type that we've created. So we'll say we'd like to make a new animal, and then we can start asking the user for information. And this will be the name and the sound for the new animal. Both of those are strings. You can also add a check to say if the farm is full, don't add anything new. We would do that by checking the size of my farm. So remember, my farm is a pointer, so we have to dereference that. And then we can check the size. So this would be one way to do that. If that is greater than or equal to the max number, then our farm is full. So remember, there's also an alternate syntax, which is what I'll primarily be using, which is this little arrow. Checking to see if the size of my farm is greater than the max animals. And if it is, then we should not add any more to it. And we'll return before we can add anything since it's full. But if it's not full, then we're going to ask for the name, ask for the sound, and then we need to add this animal to our list of farm residents, which is stored in my farm. So we're going to go into my farm, into the farm residents array. The location is going to be the next empty location of the farm, which we are going to use size for. So initially, size starts at 0. So the first guy that we add is going to go into spot 0. Then we increase the size to 1, so that the next one we add goes into spot 1. So size is not only the number of animals that we have, it's also the index for the next animal that we want to add. We'll put our new animal there. And then we need to update the size. So we're going to increase size by 1. And then we're ready to return. When we print them out, we're just going to go through all of the valid indices on the farm. So I will go from 0 to strictly less than the size. So this one is not a pointer, so we do not use the pointer notation. We just use the regular dot operator. And then we'll print out the animal, and for fun we're going to print out what kind of sound it makes. So this will be from the farm resident at I, their name, and the sound that they make. And now we'll test it out to see how it goes. Okay, so we can add an animal, see all the animals, or quit. Of course, there aren't any animals at the moment, so we can see them, but there's nothing there. So we're going to add some animals to the farm. We'll add cows. We'll add a sheep. And then we'll check to see all of the animals. So it says the cow goes moo and the sheep goes baa, and those are all of the animals on our farm. And we can keep going or we can quit. And that is our farm example. In our next chapter, we'll be looking at dynamic memory allocation in linked lists, which continues to use structures and pointers to create more abstract data types. I'll see you then.